Hello friends, my name is Madhu. From today I'm going to teach you physics, intermediate Eamcet physics. So before going to start the first chapter vectors, we'll understand the importance of vectors. See, basically physics consists of many divisions in which mechanics is one of the most important thing. Here in this pie chart we can see around 35% of the questions, 35% of the previous questions were asked from mechanics topics such as work energy, power, laws of motion, motion in straight line, motion in plane, system of rotation. All these topics are uh, which are in mechanics, which are the topics of mechanics. So before going to start these topics, we need some basics. We need some foundation chapter as vectors. So from there might not be a direct question from vectors, but with all the further chapters. So in that way, this chapter is very important to solve some good questions of this further chapters. I'm going to teach each and every chapter with a good number of examples. So we'll continue now. Okay, we'll start with vectors. I hope you understood the importance of vector. There might not be direct question from this chapter. That doesn't mean that this chapter is not important. But this concept is very important to solve the chapters, the further most very important chapters. So in that way, this is also a most important chapter. Okay. First, we'll understand what is vector. See, vector is the one which has both magnitude and direction, and also follows some vector algebra, some rules of the vectors. Okay, we all know this thing. So we'll try to understand what is direction means. What is the importance of direction? See, whenever we say some magnitude, we'll understand certain quantity is being described. Like if I say 100 kgs of rice, some quantity is being described. Like if I say 10 kgs of rice, some we can understand what does the magnitude is signifying, what does the magnitude is telling, or else if I say velocity or else some other thing, you will understand the magnitude. But what about the direction? What is the real importance of the direction? We'll understand with this simple example. See, suppose if person A is standing over here and his home is somewhere here, which is represented by H. So he want to go to his home, so by following this path, so what he will do, he will go 3 kilometers towards north and take turn towards east, and again he'll go another 4 kilometers. So here in this description, what I told, like he will go 3 kilometers towards north. See, I specified some direction which is used in day-to-day life. Again he will take 4 kilometers towards east, and by the end of the 4 kilometers he'll reach to the home. If some person says like only says the magnitude like 3 kilometers and 4 kilometers, doesn't make any sense. If they include the direction, the specific direction in specific time, or else specific point, specific path, then only he can reach his destination. So this kind of quantities are comes under vectors. Okay, such as velocity, all those things. Some examples of scalars are like mass. If we take mass, if I say 100 kgs, it doesn't, it don't require any direction. I won't say 100 kgs of 100 kgs in north direction. I won't say like that, right? Only we say 100 kgs. That's it. That's 100 kgs of mass. It's a scalar quantity. So the one which has only magnitude is called as scalars, and the one which has magnitude and the direction comes under vectors. There are many examples of vector like displacement, velocity, acceleration. We'll see them in the further classes. We'll understand those things. So now we'll start with the represent of vectors. See, in plane, the vector is represented in this fashion. The length of the vector denotes the magnitude, and the direction, the arrow towards which it's showing, will give me the idea of that particular direction. So here the both magnitude and the direction are shown in this fashion in a plane, where this thing is called as tail, the end portion, and the head, this is called as head. The one which is at the sharp corner is called as head, which is in the plane. If something which is perpendicular to the plane, suppose like z-axis, the z-axis is always perpendicular to the plane. In z-axis there are two directions, right? When the z-axis is pointing towards inside the plane, and when the z-axis coming out of something like positive z-axis and negative z-axis. If the vector is going into the plane, then that is in the negative z-axis, right? So to represent a negative z-axis, when we see a negative z-axis vector, we can see this end portion, right? So the end portion, something, it looks like this thing. So this symbol is used to explain, or else to represent the vector which is going into the plane, that is negative z-axis direction. If the arrow is coming outside the plane, like when the arrow is coming in positive z-axis, we'll see a sharp corner like a dot, small sharp corner dot. To figure out this, there is a dot, we'll round it up, or else there is no importance of this round, but there might be an accidental dot, right? So overall the symbol is like a dot with a circle. It's called as outward, when the vector is coming out of the plane, that is positive z-axis. This is a representation when the vector is perpendicular to the plane, and this is a representation when the vector is in the plane. Okay, I hope you understood the representation of this vector. So I will continue with the next one. Magnitude of vector. See, most of the people confuse that, think that the magnitude is the only numerical value, but here we must understand that magnitude consists of two things, that are numerical value as well as units. See, we'll try to understand with this example. Here the velocity is 5 meters per second north direction, because velocity is a vector and we represent it with a bar. Here 5 meters per second, both numerical value and units, both will is known as magnitude, whereas north is a direction. Okay, I hope you understood what is magnitude. Magnitude is not only the numerical value, it's numerical value plus the unit, what the quantity is all about. When we say magnitude of some vector, when we say some magnitude of vector, it is represented by modulus of the vector. Example, here above, for this vector, for vector A, this total is vector A. If I say what is the magnitude of the vector A, it is represented by this way. Modulus of vector A is equals to 5 meter per second. 5 and the unit both include the magnitude. I hope you understood this thing. Okay, we'll go to the next one. See, this is the most important thing, the properties of vector. Most of the problems can be simplified with this simple properties. Okay, we'll try to understand one after the other. Okay, if a vector is displaced parallel to itself, then the vector is unchanged, like it remains the same. Suppose there is a vector called A here. Okay, suppose a vector is there A. Okay, and if I displace this vector in certain like in some in proper way, like without changing the inclination and the magnitude, if I displace, like if these two conditions are followed and it is displaced to anywhere in the plane, then that vector which has been displaced has no change. If after displacing also this vector is A itself. I hope you understood. If a vector is displaced following these conditions, what are the conditions? Without changing the length and the magnitude, then the new vector, it's not new vector, the old vector itself, that's what there will be no change in the vector. This property is very important while solving the problems. If a complex problem can be simplified using this property, so make sure you memorize or remember this thing, shifting of vectors. This is known as shifting of vectors. The next one, see, if a vector is rotated by 360 or multiple of 360, like 2 pi or 360 degrees, then it will come back to original state. We all know this thing. If something is rotated with 360 degrees, it will come back to the original state, right? See, however, we are not changing the length, and by changing the magnitude also, we are changing in that way that it will come back to the original state again. So if a vector is rotated other than 360 degrees, multiples of 360 degrees, then the vector has no change. If a vector is changed by any other angle, like like suppose say 50 degrees, then the new vector will is entirely a different vector. Like in this example we can see vector A is rotated by angle 50 degrees. So the new vector is no more A, it's A dash. Okay, the new vector after rotating, the A and A are not same now. They are entirely different thing. I hope you understood this thing. Okay, this is also more important property to distinguish the vectors. If you understand the point number one, you can even visualize. If there is change, then this both won't be the same thing, right? Similarly, if the angle is 360 degrees, there is like no change. After rotating, it will come back to the original state. I hope you understood this second point also. We'll go to the third point. This is some people have this confusion, like what happens if a numerical value is divided by a vector. This has no meaning. If you see somewhere like this thing, like 5 divided by some vector or some random number divided by some vector, there is no meaning, it's meaningless thing. Okay, so this type of thing is not accepted. First of all, there is no this kind of things are not exist. Simply we can say. Okay, the next topic is types of vectors. See, this is something like from this topic we may expect 1 mark questions in Eamcet exam, so make sure you understand each and every point. Okay, we'll start with unit vector. A unit vector, by the name itself we can understand that the magnitude is unity or else 1, which has a magnitude of 1. And the second point states that the unit vector is unitless. What does it mean? Unitless means there is no units. Like if I say 5 meters, the meters is units, right? So there is no units. Why? Like we'll try to understand why there are no units. See, this is a formula to find out unit vectors. We'll understand from this equation, formulation. From this formulation we'll understand why it's unitless. Suppose if A was like a displacement of 5 meters, so the units were meters, isn't it? And the magnitude will also have the units, right? I already told magnitude means the numerical value as well as the unit. So magnitude will also have the same units, meters, isn't it? 5 meters, vectors by 5 meters, magnitude of that particular vector will have same units. So after cancelling, there will be no units. I hope you understood the second point, isn't it? Because the numerator and denominator have same physical quantities, there are same physical quantities. So by dividing them, we will end up with no units. So the second point is done. We'll go with the next one. It gives the direction. See, this is most important. By the name itself we'll understand. See, unit vector is all about showing the direction itself. So it will show, the main purpose of unit vector is to show the direction with the magnitude unit. So it will show suppose we'll take some simple example. If I say sugar, the unit vector, like it's not unit vector, but we'll understand a kg thing will multiply with kgs. Suppose I want 5 kgs, so multiply 5, like 5 kgs, right? 5 times of that unit. The same way unit vector is used to represent certain things in particular direction. So that's the reason. See, if I say kg, what kg? It's 1 kg, right? The magnitude over there is 1. So in the same way, it shows a particular direction. By multiplying with some numerical value, that turns into the vector what you are interested in. Okay, I hope you understood, and we'll see the problems. Then you'll get to the point. You'll understand even more. For now, it is used basically use the direction. The main important thing of unit vector is to show particular direction of particular vector. And cap, like it's not a cap, like any vector, if it's b cap in the same way. So there are some fixed unit vectors in particular direction. Like I cap is used in along positive x-axis. See the positive x-axis, please note it's positive x-axis. Okay, we'll see what happens if it is something like negative. We'll see other problems. In J is used for a positive y-axis and K is used for positive z-axis. I hope you all know these things. In the figure also you can see in x-axis the unit vector, it's of magnitude 1, is showing the direction x-axis. Okay, we'll understand. I hope you understood now. See, unit vector is showing only the direction of x-axis. This direction is like along x-axis. The main purpose is to show the direction of this unit vector's purpose is to show the direction. The next one, zero or null vector. See, what is the real importance? Like, what's the importance of a zero or null vector? If the magnitude is zero and the direction is not defined, what is the importance, or else why we use a zero vector? Because the same in algebra or in the number system, why we have zero, and the same reason applies here. To show nothing also we require some quantity, something, right? Because if I say 5 meters minus 5 meters, so how much you left with? I can't say nothing, right? I must represent with 0 meters I left, isn't it? So what I told, 0 meters, I am saying the unit. So zero vector has unit also, and the magnitude is 0, and the direction is not defined. Why the direction is not defined? Because see, if I draw some vector, some random vector like this, if the length, if there is some length, it can show a particular direction, isn't it? If there is no length, how it can show? It's like a dot, it's like a dot, isn't it? Zero, with zero length you can only make dot, not even dot. What is the direction of this dot? We can't define, right? So that is the reason, the second point, the direction is not defined, the magnitude is 0, and the unit is the same as the one which we are subtracting, or else it can have units. Simply we can have units. And the next one, parallel vectors. Parallel vectors are the one which has same direction. It doesn't bother. We won't concern with the magnitude or the physical quantities, whatever may be the physical quantities. Basically will not think about those things. The only parameter which is bothering us is the direction. That must be same. If they are same, then we'll call them as parallel vectors. I hope you understand the first point. We'll see the second point. They may represent the different physical quantities, right? Because the first point is not violating, right? If I say in this direction it's 5 meters per second, in this direction 2 meter per second. Here I told 2 meters per second. Suppose we'll take this as acceleration, like meter square per second. Here meter square per second. Okay, I hope you understood. That's 2, just like meter square. Okay, if even it's like one is velocity, another is acceleration. If their directions are same, then we can call them as parallel vectors. It doesn't bother whether they are same quantities or different quantities. We only interested in the direction. If the directions are same, parallel vector, that's it. And they may have different units as usual. If they are different physical quantities, they will be different physical, there will be different units, right? Here only we can see 5 meters per second, 2 meters per second square. One is velocity, one is acceleration. Different physical quantities, different units. Same thing. This is directly proportional, like the same point, but in different style. These statements are important in theoretical questions they may ask. Okay, I hope you understood this thing. Let's go with the parallel vectors. Parallel vectors are same as, anti-parallel vectors. Anti-parallel vectors are same as parallel vectors. Only difference is their directions are not same. They are opposite. Like if the directions are same, they are called as parallel vectors. If the directions are opposite, they are called as anti-parallel vectors. Anti-parallel vectors also obeys these 2 points. Like they may represent different physical quantities. They may have different units, isn't it? If they are different physical quantities, they will have different units. Vice versa, the same thing, isn't it? I hope you understood till here. See, one point to be noted here is unit vectors are unitless. Why? We saw the reason. and zero vectors are have units. Again, something which is interesting. And parallel vectors may have different units, isn't it? Three things have three different types. Unit vectors are unitless, zero vectors have units, parallel vectors have different units. I hope you understood what I'm trying to say about units, isn't it? Okay, let's go with the next one. Collinear vectors. Collinear vectors are the one which can be arranged. The point can is very important. The word can is very important, because by the example number 1 we'll try to understand why the can word is important. Here two vectors are not in same line, isn't it? The vectors which can be arranged in a line is called as collinear vectors. We'll think whether we can arrange them in a straight line or not. See, based on the property number 1, what we learned, it states that a vector can be displaced without changing its magnitude and the direction, right? Shifting property. By that property, I can do this system, this thing as this thing, right? Isn't it? Here I didn't change the magnitude, I didn't change the angle of inclination, and I was able to arrange this thing in a collinear fashion. So that's how these two vectors A and B turned into a collinear vectors. And here also we can see another interesting thing. These two vectors also can be arranged here. I didn't change the direction, isn't it? The C is towards this side and B is towards this side, and I didn't even change the magnitude, isn't it? Based on this example, point number 2 is arised. What is point number 2? Any parallel or anti-parallel vectors are collinear. I hope. Why? Because example number 1 is showing parallel vectors and example number 2 is showing anti-parallel vectors. Next, perpendicular vectors. Perpendicular vectors are the vectors which makes 90 degrees, as simple as this vector definition itself. One point to be noted is in a plane plane means 2D, right? In 2D only two vectors, we can't make more than two vectors. Like if there is another vector C here, suppose C, it will make perpendicular with A, but it won't make perpendicular with B. So maximum number of mutually perpendicular vectors in 2D, the mutually is very important. Mutually means simultaneously, something like simultaneously. In 2D is only 2, isn't it? Here A and B are making 1 and B and C are making 1, but C and D cannot make, right? So only two vectors can participate in mutually perpendicular vectors for 2D. When we come for 3D, it turns to be 3. How? X, Y and Z. In x-axis, y-axis, z-axis are mutually perpendicular axes, isn't it? So it can form using 3 vectors. There will be 3 vectors, maximum number of vectors which can form mutually perpendicular vectors. I hope you understood the types of vectors. Let's see some basic simple problems up to the concept what we learned, to make sure we understood the right way. Question number 1. If A and B is parallel and B and C, oh sorry, it's here, it must be parallel. Wait 1 minute. It should be parallel. If B and C are parallel, if A and B are parallel and B and C are parallel, then A and C must be parallel. Whether it's true or false is asking. Let's see the first statement. If A and B are parallel, A and B must be having same direction. So I drawn like this. Next statement, B and C must be parallel, like should be parallel. So B and C, again B and C I have drawn, and which are parallel. So now from here I can see A and C are also parallel. So the statement what it is saying, A and C must be parallel, is also true, isn't it? Okay, we'll go to the next one. If A and B are anti-parallel and B and C are also anti-parallel, then A and C must be anti-parallel. We'll see whether it is true or false. If A and B are anti-parallel, they must be having opposite direction. So I drawn like this, whether in A in this direction, B in this direction. And after that, B and C are also in anti-parallel way. So if as the B is fixed towards this side, C compulsorily, like it is compulsorily should be in opposite direction. So it's towards this direction. Based on this whole figure, we can observe that A and C are parallel to each other, and the statement it is saying is must be anti-parallel. So it is false, isn't it? I hope you understood. Next one. If A and B are perpendicular and B and C are perpendicular, and then A is perpendicular to C, we'll see whether it is true or false. First we'll draw A and B are perpendicular. A and B are perpendicular, we have drawn it. And the next statement, B and C are also perpendicular. B and C are also perpendicular. We'll see now whether A and C how they are. By this figure we can see they are not perpendicular, so it's false. Simple as that. Next one. We'll continue with the types of vectors now. The last vector is coplanar vectors. Simple. The statement itself saying coplanar. The vectors which are on the same plane are called as coplanar vectors. Two vectors are always coplanar, because see, when whatever vectors you consider in this space in random orientation, there will be a single plane which on which these both vectors are lying. You can imagine this thing. If there are two vectors in space randomly, if you place one plane, there will be a common plane through which they both are lying. I hope you can visualize this point. Number two, if it was a class, I used to explain, but I can't explain here. I hope you will understand, you will visualize this thing. So we'll stop here this lecture, and we'll continue this thing with angle between the vectors in the next class. I hope you like this video. If you like the video, please subscribe to my channel. I'll bring you content regarding this physics Eamcet. Thank you.